Good morning, everyone. I hope you guys had a great night, and I hope you guys did well on your homework. If you have any questions, please feel free to reach out to me. I'll be more than glad to help you in any way that I possibly can. So we're going to go ahead and take what we used yesterday. We're going to build on it today, and hopefully maybe today's lesson might even help you with a little bit from last night's homework as well. So kind of use maybe this as a tool to help for both. So we're going to do lesson 6.4, applications of linear systems. So for today's lesson, you're going to need some paper to take some notes with, a pencil to write those notes down with, a basic calculator just so you're adding, subtracting, multiplying, dividing. And again, if you need to use it on a cell phone, a laptop, iPad, that's all fine. And then at the end of the lesson, you're going to need the homework 53, lesson 6.4, applications of linear systems. You will find this in the yellow folder that was sent home with you guys. If you also don't have that, you can also go onto your RenWeb and you can download it as a file as well that's available to you there as the homework section or the document of our class on RenWeb. All right, so we're going to go ahead and get started today, and here we go. All right, so today we're going to talk about the first example is finding a break-even point. So when we look at something and we want to find out if it wants to break even, what do you think break even might mean? That is correct, Lakeisha. It means when things are equal to each other. So a break even point is when we have things that are even. I want to find out when does one value equal the other value. So in here we got an example about business. We have a fashion designer who makes and sells hats. So this is what they're doing. They're creating hats that they're going to sell, whether it's online through eBay or on Amazon Prime, or they have an actual brick and mortar building and they're selling their hats at the store like at the mall. So in order to start selling the hats, they have to buy materials to make the hat. So the material, we're going to highlight that piece of information because that's real important. So the material for each hat costs $5.50. So that means in order to create the hat that they're going to sell to you, they must spend $5.50 buying all the supplies that they need to create this hat. Then, after he creates his hat, he's going to sell those hats for $12.50 each. So I went ahead and marked those as well. So this is something that after he gets his hats, he's got his hats are made, and now he's going to sell them for $12.50. But just like any good business person who wants to sell their product, they've got to advertise it. That's how you want to buy those new shoes, those new hats, those new clothes, those new duds. You're looking at people's advertising. They're marketing you. They're giving something to you. So we're going to highlight that part in yellow. The designer spends $1,400 on advertising. So the reason why I've highlighted these in two different colors is because we're going to be dealing with two different things. We're going to be talking about our expenses and we're going to be talking about our income. All right, so expenses is what you have to pay. It is what the business owner or the person selling the hat has to come out of pocket before he makes any money off those hats. So there are two things that our fashion designer has to come out of pocket for before he starts selling those hats. What are the two things that our fashion designer, must come out of pocket for? That's correct, Cheyenne. The material for the hat here, and the cost of advertising, which is here. So we have something here that says, a special word in here that says each hat. That means if he only has one hat that he makes, he only needs $5.50. But if he's going to make two hats, he would need $11. And if he has three hats, he would need $16.50. So we need a variable to represent our each. So we're going to use the variable x to represent our each. So this means our expenses are $5.50 times every hat that he has to buy material for. But he also has a fee that he's going to pay for this advertising. There's no each. This is a one-time fee. He's paying $1,400 to get his product out there on the market for people to see it, be heard about it, know about it, want to buy it. So just plus $1,400 because that's a one-time fee that he's going to pay to market. Maybe later he might add more, but right now to get this business up and running, he's going to pay $1,400 to advertise his hat, and he has to pay $5.50 for each hat that he's going to make. Now, he's going to sell his hat. So that's going to be the money he brings in. So he's going to bring in, we also have that other word each again. So if he sells one hat, he makes $12.50 from that sale. If he sells two hats, now he's at $25, and so forth. So again, each is going to be represented by that variable X. So he'll make $12.50 is how much money he will earn or bring in off of every hat. So in our story problem, X is equaling the number of hats. But what we're wanting to find out is how many hats must our fashion designer sell in order to break even. So we want to know when will the expenses equal the income. So when will those two values be the same? So looking over here, we're going to use substitution. So what can we substitute expenses for? That's right, Angel. We can substitute expenses for $5.50 X plus $1,400. All right? So what can we substitute income for? That is correct, Ethan. We can substitute it for $12.50 X. So now tell me, what will we do to solve this problem? So take a moment, look at it. How would we get all of our x's together and all of our constants together? That's right, Fabian. We would subtract $5.50 X from each side. So we have $5.50 X. We're going to minus $5.50 X. And if I minus $5.50 X on the left, I must minus $5.50 X on the right. So $5.50 X minus 550 X, those cross cancel out, leaving me with 1,400. So $12.50 X minus $5.50 X will leave me with $7 X or 7X. So now we would take our 1,400 and we're going to divide each side by $7. To find our value of X. So put in your calculator your 1,400 divided by your 7, and you'll get 200. That means in order to break even, our designer would need to sell 200 hats just to break even. If he sells less than $200, he loses money. If he sells more than $200, he makes money. So the more hats he sells, the more money he'll make. But right now, 200 is the money that if he sells 200, he didn't earn any money and he didn't lose any money. He made nothing. He just broke even. He covered 200 hats, covers the cost of the materials for the hats and the advertising that it costs the expense. All right, I'm going to go ahead and move this one up just a smidge, so that the people, as we move on, can see the rest of our problem. So now we're dealing with the same business situation. But this time a person is a puzzle expert, and they wrote a new Sudoku puzzle book. So we have his initial costs are $864. Binding and packaging each book costs 80 cents. And the price of the book is $2. How many copies must be sold to break even? So now we're going to look at our story problem. We're going to determine two things. We want to highlight our expenses we want to highlight our income. All right, so we're going to highlight our expenses in yellow. So look at the story problem and tell me if you can find our first expense that the puzzle expert has to pay for. That is correct, Kanaya. Our first expense is the initial cost of $864. So we have to spend $864 just to get up and running. Are there any other expenses in this problem? That's right, Ava. Binding and packaging. So binding and packaging each book costs 80 cents. All right, so are there any other expenses? You're correct, there are no more expenses. All right, so now, what about income? Are there any other income? What is the income we get from selling these books? That's correct, Lakeisha. Our income is $2. The price of the book is $2. That means when we put our book out there on Amazon Prime and we want to sell it, we're going to sell it for $2 a book. All right, so now we've got to come back up with our variable. So what variable do we want to use for our problem? All right, so here we go. Again, I'm so sorry there was an interruption, so I came back in. I'm so sorry. So here we go again. So we're going to write down our expenses. So our first expense is this $864. So on the $864, that is a one-time fee. So there's no variable needed. It's not per book or each book. It is just a one-time fee of $864. The packaging, however, is for each book. So again, we'll use our X for our variable to represent each book. So we're going to have the cost we're going to add in there, 0.80 cents times each book. So for each book that we have packaged, it costs us 80 cents. Plus, we have to pay for that $864 for our initial cost. Now, our income is how much we're going to make on a book. So each book, we will make $2 times each book. So the price of the book is going to be for each book. And we're going to let that be represented by our X. So now we want to find out again, when will our expenses equal our income? All right, we're going to go ahead and substitute. So what value are we going to substitute expenses for? That's right, Isaiah. We're going to substitute it for 864 plus 0.80 cents X. And for our income, that's correct, Mia, $2 X. 2.00X. Okay. So now we want to get all of our variables together. So how can I move all my variables to one side and leave my constants on the other side? What should I do? That's right, Ethan. I'm going to subtract 0.80 cents from each side. So I got my 864. So we have 0.80 cents X, and then I minus 0.80 cents X. Pretty simple. 0.80 cents X on the left, which means I have to subtract 0.80 cents X on the right. So on the left, 0.80 cents X minus 0.80X, those cross cancel each other out, leaving me with 864. On the right, $2 minus 80 cents is equal to $1.20. So 1.20X. Now what do? That's right, Juan. We divide each side by $1.20. We're going to do 864 divided by $1.20. So then X is equal to 720. That means how many books do we have to sell to break even? That's right, Lakeisha. We need to sell 720 books. That would be my final answer. So what this tells us, in order for me to not lose money, and in order for me not to make any money, I have to sell 720 books. So this puzzle expert has to sell 720 books. If they sell less than 720 books, they lose money. If they sell more than 720 books, they make money. So be sure at any time throughout this lesson, if you need to pause, rewind, watch over again, please do so. Take any notes that you have. And if you have any questions, write them down and send them to me. All right, we're going to move over to example 1 practice time. So now you're going to try 2 problems all by yourself. So what I want you to do is after I explain the directions, I want you to pause the video, try to solve first and the second problem, and see if you come up with the correct answers. If you do, you're going to go whoop whoop in the house, you have a pat on the back. If not, make some notes. Tell me where you got lost, send it to me, and I'll be more than glad to help walk you through it. All right, so go ahead at this time and pause your video. All right, so what I'm going to go ahead and do is realize that when this year I wanted to find when we're going to break even. So I need to know a little bit about my expenses, and I need to know some information about my income. So I'm going to read my story problem. A bicycle store costs $2,400 per month to operate. The store pays an average of $60 per bike. The average selling price of each bike is $120. How many bicycles must the store sell each month to break even? So first I'm going to identify what are my expenses, and I'm going to highlight my expenses in yellow. So it cost me $200. Oops, that's not yellow. It cost me $2,400 a month to operate my business. And then I paid an average of $60 per bike. Now I'm going to highlight my income in blue. So my average selling price of each bike is $120. So now I know here what my expenses are and what my income is. Okay, so now I know that I'm going to pay an average of $60 per bike. This per is kind of like the word each, that represents an X. So I'm going to say I've got to pay $60 per bike out of pocket. So when I go buy my bike, I'm paying $60 a bike for them. And then I have to pay monthly fees to operate my bike shop. So I'm going to say plus $2,400. At this time, I'm not going to put the variable, even though we see the per, we're only going to deal with 1 month right now, or start with, and then we'll go from there to see how many months after that that would work. So this $2,400 is what it cost me to operate my business. So now we're going to take the selling price of my bike, which is another each, so X. So I sell my bike for $120 X. To break even, I want to know when will my expenses equal my income. So I take and substitute my expenses for 60X plus 2,400. And I'm going to substitute my income for 120X. I want to get all my variables on the same side and all my constants on the other side. So I'm going to move my 60X to the right side where the 120X is. The opposite of positive 60X is minus 60X. And if I subtract 60X on the left, I must subtract 60X on the right. 60X minus 60X cross cancel each other out, leaving me with 2,400. And 120X minus 60X is 60X. Now I need to divide by the coefficient of 60. This cross cancel leaving me 1X. And 2,400 divided by 60 is equal to 40. That means in order to break even, I would have to sell 40 bicycles. All right, problem number 2. A theater producing a musical costs $88,000 plus $5,900 per performance. Once sold out performances earns $7,500 in revenue. If every performance sells out, how many performances are needed to break even? All right, so I'm going to go ahead and take my yellow highlighter, and I'm going to go ahead and highlight all of the things that I think are expensive. So producing a musical costs $88,000. That is definitely expensive. Plus, I have to pay $5,900 per performance. That's another expense I have to pay. Now, income, I'm going to highlight in blue. I noticed that one sold out performance earns me $7,500. So one sold out performance earns me $7,500 in revenue. So now I'm going to go back and look at my expenses. And my income. And I'm going to see what we can come up with. All right, so what I've determined on my expenses are, it cost me $88,000 just to produce the musical. So $88,000 to produce the musical. Plus, I paid $5,900 per performance. So that's going to be an X. So $5,900 for one performance. Then it would be $11,800 for two performances. So that's why my X is in. Then I'm going to look at my income. One performance earns $7,500. And if I'm trying to find how many performances, I need to find out how many performances would make these guys the same value. So my question is, when will my expenses equal my income? So what are we going to substitute our expenses for? That's right, Angel, 88,000 plus 5,900X. And what are we going to substitute our income for? That's right, Cheyenne, 7,500X. All right, so now what will we do next? Who thinks they might know what we do next? That's right, Tanaya. We would subtract 5,900X from each side. We want to get all those variables together. So if I have a plus 5,900X, I must subtract 5,900X to make it go away. And if I subtract 5,900 on the left, I must subtract the 5,900X on the right. So to take my 88,000, bring it down, plus 5,900 minus 5,900 goes away, and 7,500 minus 5,900 is equal to 1,600. So this is down a little bit so you can see. X. All right, so now what do we do? That's correct. We divide by 1,600 on each side. So these cross cancel out, leaving me with 1X. And 88,000 divided by 1,600 is equal to 55. So this means we would have to perform 55. So we need 55 performances. Sold out performances in order to break even. We need 55 sold out performances in order to just break even. If we have less than 55, we lose money. We have more than 55, we make money. So our goal here is to have a whole bunch more than 55 performances. All right, so we're going to go ahead and move on to example 2. I hope you guys did really well on this and did some, if you didn't, maybe you could see where you may have made a mistake and be able to correct it. All right, so example 2, we're going to talk about constraints and viable solutions. All right, so let's read our sort of problem, and then we'll take it from there. So it says, we're talking about a zoo. It says the local zoo is filling 2 water tanks for the elephant exhibit. contains 50 gallons of water and is filled at a constant rate of 10 gallons per hour. The second water tank contains 29 gallons of water and is filled at a constant rate of 3 gallons per hour. When will the two tanks have the same amount of water? Okay, so right now we first need to identify what things are we talking about. So in this problem, we're talking about two different types of water tanks. We've got a water tank 1 and we have water tank 2. So let's first identify it. We have tank 1 and we have tank 2. All right, so what we want to do here is to look at our water tank. Tell me what you know about the first tank of water. That's correct, Fabian. It contains 50 gallons of water. What else do we know about our first water tank? That's correct, Isaiah. It is filled at a constant rate of 10 gallons per hour. So I'm going to take and highlight that first water tank value in yellow. So one water tank contains 50 gallons of water and it's filled at a constant rate of 10 gallons per hour. So that's what I know about tank 1. All right, so let's write some information about that tank 1 then. All right, so how would it show having 50 gallons of water and then being filled at a constant rate of 10 gallons per hour? All right, that's right, Tanaya. We would start out by saying we already have 50 gallons of water. And then we're going to add to this because I already have 50. And then I'm going to fill it, so I'm going to add 10 gallons per hour, so 10x. Now we're going to highlight the information about water tank number 2 in blue. So the second water tank contains 29 gallons of water and is filled at a constant rate of 3 gallons per hour. All right, so Laquan, how would I write this one? That's correct. 29, because that's how many gallons of water we have. Being filled, so yes, plus. And then 3x, because 3 gallons per hour. So the question says, when will the two tanks have the same amount of water? Well, same means what in mathematical operation? That's correct, Ethan. It means equal. So I want to know, when will tank 1 equal tank 2? All right, so Mia, what would I do to replace tank 1 with? That's right, Mia. 50 plus 10x. All right. Who knows what we replace tank 2 with? That's right, Amaya. 29 plus 3x. Now, remember I was saying that we have variables on both sides, and we have constants on both sides. And our variables go to the left, constant to the right, then work it out, So, Amaya, how would I move my variables to the left, That's correct. I would subtract 3x from each side. So on this right side, I have a positive 3x. To remove it and make it go to the left side, I minus 3x. And if I minus 3x on the left side, I must minus 3x on the left side as well. So here I have 50. All right, so I've got 50. And then 10 minus 3x is 7x. Have my 29. And then 3x minus 3x go away. So how do I move my constants to the left, to the right, How do I move myself around? That is right, Angel. I subtract 50 from each side. So 50 minus 50. And then 29 minus 50. That takes my constant from the left to the right, 50 minus 50 go away, leaving me with 7x. Then we got to subtract 29 minus 50 is equal to a negative 21. Now what would we do? We move this down a little bit, we'll come back. A little more space to right, and then we'll come right back in there. All right, yes, you're correct, Ethan. We'll divide each side by 7. So these cross cancel out, leaving what x is equal to negative 3. Now you notice we got x is equal to negative 3. And x was representing our time. So our time was saying that it'd be negative 3. And we're doing this per hour, so negative 3 hours. Is it possible to have negative 3 hours? No, it is not possible. You were right. Since you can't have negative time, this is not a viable solution. This means there will not be a time when these two tanks will equal one another. Because one tank maybe starts too high, or the rate that's filling it is too slow, or one is filling up way too fast to ever catch up. So this means this is not a viable solution. So our final answer would be not a viable solution, because we cannot have negative time values. Negative time values cannot exist. All right, I'm going to go ahead and move the screen up. If you need to see this or hold on to it, just go ahead and pause your video, finish your notes, and then when you're ready to continue writing your notes, press play, and you'll see what we picked up. All right, so we're going to move the Zoom. Bring it back down into view for us. Now we're going to do our Zoom. All right, so we got another Zoom this time. It has two other water tanks that are leaking. So now they've got two other water tanks that are leaking. One tank contains 10 gallons of water and is leaking at a constant rate of 2 gallons per hour. And the second tank contains 6 gallons of water and is leaking at a constant rate of 4 gallons per hour. Now our other tanks are filling up. These two tanks are leaking. So instead of gaining water, these two tanks are losing water. So I'm going to go ahead and highlight in yellow the information I know about the first tank. So one tank contains 10 gallons of water and is leaking at a constant rate of 2 gallons. And highlight our second tank in blue. So our second tank contains 6 gallons of water and is leaking at a constant rate of 4 gallons per hour. So again, we've got two tanks. We have tank number 1 and we have tank number 2. All right, so tank number 1 already starts out with how many gallons? That's right, Ava, 10. If it's leaking, do we add or subtract? That's right, Shai, we subtract. And how much do we subtract, Amaya? You're correct, 2x. Good job for knowing to use that variable. I'm so proud of you. So tank number 2, Angel, how much does tank number 2 start with? That's right, 6. And then it's leaking, so what does that mean, Angel? You're right, subtract. And how much are we subtracting? That's right, Lakeisha, 4x. So 4 gallons per hour. Good job using that variable. I'm so proud of you guys. So we want to know, when will the tank have the same amount of water? So we want to find out, you're right, Laquan, when does tank 1 equal tank 2? All right, so Cheyenne, what do we do next? You're correct. We substitute the values in, all right? So what are we going to replace with tank 1, Shy? That's right, 10 minus 2x. And Fabian, what are we going to replace with tank 2? You're correct, 6 minus 4x. All right, so now what are we going to do? That is correct, Ethan. We're going to move our variables to the left, to the left. So how do I move this variable on the right to the left, Ethan? That is correct. Add 4x. So on this side, we have a minus 4x. So the opposite is plus 4x, like Ethan said. So if I add 4x on the right, I must add 4x on the left as well. So I'm going to combine my like terms. Negative 2x plus 4x makes a positive 2x. And then I have my 6. Negative 4x plus 4x cross each other out. How do I move that constant to the right, to the right? That's right, Cheyenne. I subtract 10. So 10 minus 10 plus 2x, and then 6 minus 10. Well, 10 minus 10 cross cancel each other out, leaving me with 2x. 6 take away 10 is negative 4. All right, so tonight what do? That's right, we divide by 2. So then x is equal to a negative 2. So what does even stands for hours and time. So that means we're saying our time would be -2 hours. Can you have -2 hours? That's right, Ava, we can. So what would our answer be? That's correct, Mia. Not a viable solution. The answer to our problem would be not a viable solution. All right, so now we're going to go ahead and move on to some practice time. For example, 2, we've got 2 problems, investment and biology. Just like practice time, for example, 1, what I want you guys to go ahead and do is try to solve the problems, and then you can resume the video. So make sure you pause the video first, so you have the problems up here, and then try to solve the problems, and then resume the video as you see that you're ready, and I will be working out the steps. So go ahead and pause your video at this time. All right, here we go. So we're going to go ahead and look at our first problem on investment. All right, so our investment says you split $1,500 between 2 savings accounts. I'm going to take and highlight that first of all in yellow. So we split $1,500 between 2 savings accounts. So we have 2 different types of savings accounts that we're going to do. We have a first account and our second account. So I'm going to go ahead and give those, since they're 2 separate accounts. We have account 1, account A, and we have account B. All right, so account A, I'm going to let be represented by X, and I'm going to let account B be represented by Y. Those are 2 accounts. So if I take the money that I have, I got to first figure out how much money do I have. I have $1,500. So the amount of money that I put in account A plus the amount of money I put in account B will equal $1,500. So that's kind of where I'm starting at. But I'm going to erase that in a second because I know that account A is the same as X and account B is the same as Y. So I'm going to go ahead and take this out and rewrite it and say that X, which is account A, plus Y, which is account B, is equal to $1,500. Now, I find some other interesting information about account A. Account A pays an annual interest of 5%. Annual means once a year. So account A is paying 5%, that's 5% at the decimal, 0.05, per year. That means I have to multiply my X by 0.05, so 0.05X. Then I found out that my account B paid 4% annual interest. So I paid 4%, so 0.04 per year. So I'm going to write that as 0.04Y. But after 1 month, or 1 year, the amount of money that I have earned is the total. So total means we're going to add the money that I made from account A in 1 year, plus the amount of money that I made in account B in 1 year, equals $69.50. Now this problem looks a lot like what you did yesterday. So I'm looking at my coefficients of the x's, they're not the same. The coefficients of my y's are not the same. But I know that 1 will go into 0.05 times. So I'm going to go ahead and multiply everyone on the top by 0.05. When I do this, I get 0.05x plus 0.05y using that distributive property, and then it will equal 75. The second equation I didn't do anything with, so it just stays 0.05x plus 0.04y equals 69.50. Now I look at my 2 x's, I have done the first step, which means now I have them with the same coefficient. So the same coefficient, I asked myself, do they have the same sign or do they have different signs? And they have the same sign, so they're the same sign, I subtract. So we're going to subtract all three columns just like on last night's homework. So 0.05x minus 0.05x, they cross cancel each other out. 0.05y minus 0.04y leaves me with a positive 0.01y. And $75 minus $69.50 leaves me with $5.50. Then I will divide by 0.01 on each side so that I have 1y. So then 1y is equal to 550. Then I'm going to substitute y into the first equation. So I have x plus, I'm going to substitute into y, and it will equal 1,500. So my 550 in here. So there's no multiplying to do here. So I just have x plus 550 is equal to 1,500. To get my x by itself, the opposite of plus 550 is minus 550. And if I minus 550 on the left, I have to minus 550 on the right. So I have my x plus 550 minus 550 marked away. 1,500 minus 550 is equal to 950. So this means, I'm going to raise this right here for a second so I can put the amount of money. All right, that means in 1 year, I'm going to invest in account A $950 because that's what X is equal to. And account B, I'm going to invest $550 because that's what the Y value is for with account B. So my final answer is account A $950 and account B $550. I know that may have been a little bit tough, a little bit challenging, but I have confidence that you guys, once you read through this one, you're going to do really well on the second practice time. So what I'm going to go ahead and do is scroll the screen up. Feel free to pause, review, write down notes, ask questions, be ready to ask them for the to get your mind. All right, so go ahead and extend the page on that. All right, so we're going to talk about example 2, which is biology. We have a group of scientists who study the effects of a chemical on various strains of bacteria. Strain A started with 6,000 cells and decreased at a constant rate of 2,000 cells per hour after the chemical was applied. Strain B started with 2,000 cells and decreased at a constant rate of 1,000 cells per hour after the chemical was applied. When will the strains have the same number of cells? Okay, so first thing we're going to do is look at what we have. We have 2 strains of bacteria. We have strain A and we have strain B. And the question is asking us is when will the strains have the same number of cells? So we want to know when will strain A equal strain B. So let's go find some information about what we know about strain A and strain B. I'm going to highlight strain A in yellow. So strain A started with 6,000 cells and decreased at a constant rate of 2,000 per hour after the chemical was applied. So I'm going to write some information about that then. So if my strain A started out with 6,000, so 6,000, I'm going to do it over here instead, guys. I'm going to do a little bit faster. So 6,000 is where we started out with 6,000 strand cells in our strand, and a decrease, so minus, at a constant rate per, so this is where my variable x will come into play, of 2,000 x. So now I'm going to move on to strain B. I'm going to highlight this information in blue. All right, so strain B started with 2,000 cells and decreased at a constant rate of 1,000 cells per hour after the chemical was applied. All right, so I'm going to write that information. So I know it started out with 2,000 cells and decreased at a constant rate of 1,000 cells per hour. All right, so now I'm going to do my substituting. I'm going to replace strain A with 6,000 minus 2,000x and equally 2,000 minus 1,000x. All right, I want to get all my variables on one side and all my constants on the other. So for this problem, I'm going to go ahead and move my negative 2,000x to the right-hand side. The opposite of minus 2,000 is plus 2,000. And if I add 2,000x to the left side, I must add 2,000x to the right side as well. So I have my 6,000, negative 2,000 plus 2,000x cross out, leaves me with my 2,000, and the negative 1,000 plus 2,000 is a positive 1,000x. I'm going to move my constant to the left, go to the opposite of plus 2,000, which is a minus 2,000. If I subtract 2,000 on the right, I have to subtract 2,000 on the left. So 6,000 minus 2,000 is 4,000. 2,000 minus 2,000 cross cancel each other out, leaving me with 1,000x. Now we would divide each side by 1,000, and we do this because that's the coefficient of the x, and we want to get our variable with a coefficient of 1. So 1x is equal to 4, because 4,000 divided by 1,000 is 4. I will now substitute my x in either to strain A or strain B's equation. It doesn't matter because these values are supposed to be equal. So I'm going to substitute in strain A. So I'm going to do 6,000 minus 2,000 times x. And we said x is 4. So we have 6,000 minus 8,000, which is equal to negative 2,000. So what my solution is telling me is that after 4 hours has gone by, there'd be negative 2,000 cells. Well, we know we can have 4 hours times, that's fine, 4 hours can pass by. But you can't have negative cells. Since you cannot have negative cells, this cannot occur, this is not a viable solution. Final answer, not a viable solution. All right, we're going to go ahead. Make sure you put any notes down or ask me any questions or review this if you have any. We're going to move on to our final example, example 3 today. All right, so example 3 is solving a wind and current problem. So when we have wind, when you have the wind with you, it adds to your speed. It's like it's pushing you. So our airspeed right here plus the wind speed will equal our ground speed, because it tells me how fast I can move because I'm getting extra speed built into it. But if I have wind speed, my airspeed of the air, and then the wind speed is, I'm going against the wind, means I'm having to fight it, it's slowing me down, so there's a minus the wind speed, and that will equal the speed on the graph. So when a plane travels from west to east across the United States, the steady west to east wind acts as tailwind. This increases the plane's speed. So tailwind is pushing you. But when we go back from east to west, the wind acts as a headwind. It means you're going into the wind. And this decreases the speed relative to the ground. So we're going to look at a problem here about a traveler who travels or flies from Charlotte, North Carolina to Los Angeles, California. So they go from Charlotte, North Carolina over here to LA, California over here. At the same time, another traveler is going to go from LA and make their way over to Charlotte on the East Coast. So we got a traveler traveling from East to West Coast and a traveler going from West to East Coast. So the airspeed of each plane is the same. So they're both going to be traveling the same airspeed. So airspeed is we don't know, we're going to go find, because that's our question. What is the airspeed? So we're going to look at our two equations. So from west to east, that means we're going to start in California, and we're going to go to Charlotte, North Carolina. I'm going to be having the tailwind behind me pushing me. So that would be that A plus W equals S, or G. So we're going to use that. So A, airspeed, plus the tailwind is equaling my ground. Then we'll have the person traveling from Charlotte, North Carolina to Los Angeles, California. They're going to have their airspeed, which will be the same, but we're going against the wind. We're hitting that headwind, so minus our wind speed will equal our ground speed. So those are our two equations that we're going to be dealing with. Now we're going to take those two equations, and we're going to go ahead and look at what we know about any of this. So right now, we look at the story problem here. We know that in this first bubble, what our ground speed is for the plane traveling from LA to Charlotte. The ground speed is 550. So what we're going to go ahead and do is take out this ground speed, and we're going to replace it with 550. And we know that the ground speed for the plane traveling from Charlotte, North Carolina back to LA has a headwind, and it has a ground speed of 495. So I'm going to replace that ground speed with 495. Now we're going to use the information that we had from yesterday. We look at our coefficients, our A values. They are the same, but they both are 1, and they have the same sign. So we could subtract these two. But look at our W's. Our wind speeds also have the same coefficients of 1, and they have opposite signs. So they have different signs. We can add these two equations and eliminate the W's, and you don't have to deal with subtraction and messing up your signs so much. So 1A plus 1A makes 2A. 1W plus negative 1W cancels out. Then we add 550 plus 495, and we get 1,045. We then divide by 2 on each side. So 1,045 divided by 2. These 2's cross cancel out, leaving me with 1A is equal to 522.5. This means my airspeed is equal to 522.5, I'm sorry, 522.5 miles per hour. If we wanted to find the speed of the wind, what would we do? Who thinks that we know how we could find our wind speed? That's right, Fabian. I would substitute the A value back into the first equation. So I'm going to substitute my A value into the first equation, plus 1W equals 550. So substitute that 522.5 plus W. All right, so we have nothing here to multiply, so we just have 522.5 plus W equals 550. Now what we do, that's right, Lakeisha, we subtract 522.5 from each side, so 522.5 minus 522.5 on the left. And then on the right, we have to do the same as well, minus our 522.5. These cross cancel out, leaving me with W. So 550 minus 522.5, and we get 27.5. That means my wind speed would be 27.5 miles per hour. So the problem this time asks us for the airspeed of each plane is the same. They did not ask us for the wind speed. We just went above and beyond and found that. So the only answer we really needed was our airspeed. But I wanted to to make sure you can be able to find the other if you need it. All right? So now we're going to give you some practice time. We're going to have you do these 3 problems here: rowing, airports, and kayaking. So you'll try each problem, you'll pause the video, and then you'll resume and check your answers. So I'm going to go ahead and get started with the rowing one. So at this time, go ahead and pause your video. Okay, so we're going to look at the first one on rowing. It says you row upstream at a speed of 2 miles per hour. You travel the same distance downstream at a speed of 5 miles an hour. What will be your rowing speed in still water, and what is the speed of the current? All right, so in order to set our equations up, we need to figure out what we are talking about. What things are affecting us going upstream and downstream? So the 3 things we're looking at that we have to deal with. We have the rowing speed. We have the still water. And then we have the current. So those are 3 things that we're dealing with. So I'm going to let the rowing speed be represented by the letter R, still water by the letter S, and the current by the letter C. All right, so what we know is when we travel downstream, so I'm going to highlight that in yellow so I can see kind of what I'm talking about. You travel the same distance downstream at a speed of 5 miles per hour, and our upstream is you row upstream at a speed of 2 miles an hour. So what it's saying is here, our distance is the same. So whether we're going rowing 5 miles, 10 miles, 30 miles, 40 miles, I'm covering the same amount of distance, but just how fast I can go per hour depends upon whether I have the current with me or the current going against me. So that will indicate my rowing speed. So if there was no current, both trips, whether it was upstream or downstream, would have the same still water. So if I'm going upstream, the still water would still be the same speed as if I went downstream. So if the water was still, didn't move, there's no current, just standing still, that is the basis that we're setting everything off of. If we're going to row upstream, if we're going to go upstream, means we're going to go against the current. So we're fighting the current. And then this would equal how fast we would have to row. If we're going to go downstream, then we have the current with us. So the current is helping us go faster. Then that will help determine what our row speed would be. Well, if we're going upstream, it said my row speed is 2 miles per hour. So I can take out my row speed, R, and replace it with 2. It says my downstream speed is 5 miles per hour, so I can take out my rowing speed of R and replace it with 5. So now I can look at my 2 problems and see that both the coefficients of the S's and the C's are the same coefficients. But I notice my C's have opposite signs, so I can add these 2 guys up and not have to worry about messing up with subtraction. So 1S plus 1S makes 2S. Negative 1C plus positive 1C cross cancel each other out. And 2 plus 5 is equal to 7. We now divide on each side by 2. That means the 2's cross cancel out, leaving me with 1S. And 7 divided by 2 is equal to 3.5. That means the still water, because that was asking us what would be your rowing speed in still water and what was the speed of the current. They want us to find out what is the S value, and they want us to find out what is the C value. They want you to find both values. We just found S, so our still water is equal to 3.5 miles per hour. Oops. I'm a little bit too low on that one. So now I want to find out the C value. So I'm going to substitute this value. I'm going to use the second equation since it's being added to make it a lot easier on us. So S plus C is equal to 5. So I replace S with 3.5. So there's nothing I can multiply with other than 1. So I have my 3.5 plus C is equal to 5. I'm going to subtract my 3.5 from each side. 3.5 minus 3.5 cross cancels each other out, leaving me with a positive 1c. And 5 minus 3.5 is 1.5. That means my current is equal to 1.5 miles per hour. This is your final answer. All right, we're going to go ahead and cover the airport one. We have a traveler who is walking on a moving walkway in an airport. The traveler must walk back on the walkway to get a bag he forgot. The traveler's ground speed is 2 feet against the walkway and 6 feet with the walkway. What is the traveler's speed off the walkway, and what is the speed of the moving walkway? So let's look at the things that we have talking about here. We have got the ground speed. We have the traveler on the walkway and off the walkway. And it's still walkway, right? And we have off walkway. All right, so let's get to the variables. All right, so let's say we'll do our ground speed is g. The traveler is walking against it or walking with it. So we're going to say the walkway will just be the standard walkway. I mean, there's no speed to that, it's just this. Then we got the speed of how fast that walkway is moving that kind of makes it go faster. So we'll use S for the speed of walkway. I'm just going to change this around. Make this off the walkway. So this is this walkway. Change that word. So walkway, and then all right, we'll go ahead and make the off walkway and with walkway. Okay, so if we are having our ground speed, so we'll say G, our ground speed for each. And standard walkway, just off the walkway, you walk at normal, that's W, that's not going to change. But if you're going to go with the walkway, you're going to add some speed. If you go against the walkway, you're going to subtract the speed. So we're going to use our highlighter and highlight what we know about with the walkway. All right, so if we're going to go with the walkway, let's figure out where that would be in our third column. So we got with, right here, with. So with the walkway, it tells me I'm going 6 feet per second. So with the walkway, I'm doing this. So I'm going to go over here and take out with my G, my ground speed will be 6 with that walkway. That will right. Right. I'm going to change it again. I'm sorry, guys. All right. So now then we're going to find out against the walkway. So we're going to go against the walkway. Let's highlight that in yellow. All right. So we're going to go against the walkway, and that'd be 2 feet per second. Let's go ahead and change that. So we're going to go against the walkway. We're at 2 feet per second. Now I'm going to take this guy here and move this guy up here a little bit closer so we have a little bit more room. And then we'll go ahead and get started after that. All right. So here we go. So now, since my coefficients of both the W's and the S's are the same coefficient, I notice that the coefficient of my S's, opposite signs, are different signs, so I can add. So 1W plus 1W makes 2W. Positive 1S plus negative 1S cross cancel each other out. Then I have 6 plus 2, which is 8. I'll divide each side by 2. So 8 divided by 2, because these 2's cross cancel out, leaving me with 1W. And 8 divided by 2 is 4. So now I know my speed off the walkway. So off the walkway is equal to 4 miles per hour. So now I'm going to find my speed with the walkway. So to do that, I'm going to substitute this W for 4 in the first equation. So 4 plus S is equal to 6. Again, I can't multiply anything, so I just have 4 plus S. And to get the S by itself, the opposite of plus 4 is minus 4. And if I minus 4 on the left, I must minus 4 on the right. The force cross-cancel each other out, so positive 1s is equal to 2. So the speed of the walkway is 2 miles per hour. All right. All right, so our final one on our kayaking, we have a kayaker who paddles upstream from camp to photograph a waterfall and return. The kayaker's speed while traveling upstream and downstream is shown below in the picture. What is this kayaker's speed in still water, and what is the speed of the current? So we have still water, and we have current, and we have paddling. So we got still water that we have to find the answer for, and we got to find the current. So we know that both situations, whether you're traveling upstream or downstream, the still water will be the same in both situations. But if I'm going upstream, I get to take the current with me. And if I'm going downstream, I take the current against me. And how fast I have to paddle depends upon whether or not I have the current with me or against me. For this picture, if your paddler is going upstream, his speed is at 7 miles per hour. That's how fast he is paddling. But if he's going downstream against the current, then he's only paddling 4 miles an hour. So again, my coefficients of my S and my speed are the same coefficients, but my speed coefficients have opposite signs, so that means I can go ahead and add these two. 1s plus 1s makes 2s. Positive 1c plus negative 1c cross-cancel each other out, and 7 plus 4 is 11. Then I divide on each side by 2, so the 2's will cross-cancel, leaving me with 1s. And 11 divided by 2 is 5.5. So it means the speed of my still water is 5.5 miles per hour. To find the speed of the current, I will substitute this s into the first equation. So 5.5 for my s plus my current c is equal to 7 miles per hour paddling. There's no multiplication to take place, so I just have 5.5 plus c equals 7. To get the c by itself, we subtract 5.5 from each side. So 5.5 minus 5.5 plus c is equal to 7 minus 5.5. 5.5 minus 5.5 cross-cancel each other out, leaving me with 1c. And 7 minus 5.5 is 1.5. That means my current speed is 1.5 miles per hour. This would be my final answer. I hope you guys did fantastic today. I hope you got a whoop whoop in the house and a pat on the back. If you get stuck with any questions or need help along the way, please be sure to write this down and send them to me to remind. Love and miss you guys, and I can't wait to see you again. Have a good evening.